So as you can tell in these first equation they give us, it kind of shows you just a normal growth and decay type of equation with A represents the amount, P represents principal, and then the 1 plus R is rate. And note that the rate is written as a decimal, so make sure you're writing it as a decimal. N represents the number of times of compound interest per 1 year. So if it says annual, that'll be 1. If it says semi-annual, that'll be 2. If it says quarterly, that's 4. So you kind of see how many times does it actually get compounded throughout the year. And then, of course, you raise it to the N times T, and T represents time in years. Going across, a PERT is usually talking about a continuously growing type of function. And then at the last, it's kind of a this one is just more of a general growth or decay type of problem here. So that stuff you'll usually see with like bacteria, like science. You usually see this kind of stuff as well there, okay? The first one you see financial, with money and stuff. All right, so let's look. On the day of his child's birth, the deposit of $25,000 is made in a trust fund that pays 1.25% interest. Determine the balance of this account on the child's 26th birthday if the interest is compounded quarterly and then if it's compounded continuously. So the first one we're going to look at is going to be quarterly. And so we'll go through and identify all of our variables, like you do in physics. So the idea is on the child's birthday, deposit was made, so that is your principal. That's the first amount, is $25,000. The trust fund that pays 1.25%, so the rate is 0.0125. Determine the balance of this account on the child's 26th birthday. So time is going to be on 26 years. And it goes on to say compounded quarterly and then compounded continuously. Well, quarterly, how many times is that a year? 4. So N is equal to 4. So we use our equation on the left side because it's talking about finances and investing, and we plug in everything we know and see what we get from there. So we need to know the amount. That's the unknown. Initial principal is $25,000. Then it's 1 plus, and we're looking at the rate, which is 0.0125. And that is split up 4 times throughout the year. So divided by 4, raised to the 4 times 26. And that's something you just plug into your calculator and find your answer and see what you get. So 25,000. 1 plus alpha y equals 0.0125 over 4 raised to the 4 times 26. That's right. When it matures, you'll have a total investment of $34,583.24. Not bad. Made $9,000 just sitting in a bank doing nothing, so that's a pretty good deal. Did take a while, but that's normal. So let's go and look if this was compounded continuously. So we come over here and look at continuously. Again, our principal is $25,000. Our rate is 0.0125. Our time is 26. So let's see what we get here. Amount equals the principal times E raised to the 0.0125 times 26 power. And so what you notice is, after you put that in your calculator, it's second ln, which is the number next to the 4. To the left of the 4. There you go. So which investment's going to be better? Continuous by only like $17, but still it's better, right? Buy a meal. That's right. Every dollar counts, that doesn't it? All right. So that's how you work through those, guys, is go ahead and use the formulas. The formulas will be given to you on the test, so you don't have to worry about memorizing those. Just know where each one uses them for what. So we'll move on to the next one. Sam got a new car for graduation. Parents bought the car for $19,250. Expects it to depreciate in value for about 7.9% per year. How much will it be worth in 6 years? So we're looking at now, there is dollar signs here, granted, but we are talking about a decay type of scenario. You buy a car, you keep it, every year the car depreciates in value. So we're talking about decay. So we're looking at the formula where, I need something else to look off of. So let's go ahead and define our variables here. So the first thing is the amount, or the principal, is going to be $19,250. The rate of decay, so the rate is going to be 0.079 per year, and the time is for 6 years. And so I can't see up at the top of the equation, but I'm guessing that it's going to be the amount is equal to your principal value 1, and then on the equation to the right, it's 1 plus or minus. Well, we're talking about depreciation, so we're going to add or subtract, guys? Subtract. So we subtract the rate. Thank you, Dylan. 0.0, what, 76? 79? And then you raise that to the time, which is going to be 6. So 19,250, 1 minus 0.079, raised to the 6th power. And so after 6 years, that car should be worth $11,748.60. Any questions about decay? Just got to read through the problem, guys, and know which formula to pick. And then from the formula of decay or growth, just determine, is it getting larger, is it getting smaller? Right, you receive a gift of $17,500 that you put into account. It's a nice, generous gift. With an interest of 0.75%, and plan on leaving it in the account for 10 years. Determine the balance of this account if the interest is compounded weekly and continuously. All right, so this is a repeat of what we did on number 1. So I want you to guys go ahead and do it on your own using the guide for problem number 1. Pretty straightforward on these first few problems. However, it can get a little bit complicated in the fact that we need to sometimes solve for time. Okay? So let's go ahead and see if I can jump to a problem. Number 5. Perfect. Number 5 is a good one we can look at, okay? Number 5 says, determine the number of years it would take for $50,000 to double if the investment at 2.5% per year compounded daily. Okay? So we're looking at, well, our principal, well, that's initial investment, is $50,000. What's our amount going to be if we're talking about doubling it? Then we talk about our rate. Was it 2.5? Oops, not 2 zeros, 1 0. Time is, well, that's what's in question, isn't it? Isn't time in question? And then we're compounding it, which is n is 365. Whoops. So then we go ahead and say, all right, here's all of our variables. So let's go ahead and use the equation. The one we're going to use, we're talking about investment because we are talking about N. It's compounded a certain amount of time, so we're going to have to use that first equation on the left side. So the amount is 100,000 equals our initial investments, 1 plus our interest rate, which is 0.025, over the number of times it's compounded, which is 365, and this is where the variable comes in. Time times N times T, right? Well, we know N is 365, and T is what we're actually finding. Well, kind of a big little mess here, isn't it? So let's go ahead and see if we can clear this up as much as possible, okay, guys? First off, I'm going to figure out what's going on inside the parentheses. So 1 plus 0.025 over 365. And you get pretty close to 1. It's like 1.000068493. We are solving this equation for t, correct? So what we have to do is get that exponential part of the equation by itself. That 1 raised to the 365t needs to be an equation side all by itself. So what do I need to do here in order to get that by itself? Divide. So you end up with 2 is equal to 1 raised to the 365t. Well, why did I put 2? T. So what do we do here in order to solve this? What have we done? Close. Right? If the question, the variable in question is an exponent, you have to use log. You have to get rid of the exponential situation. So log base 1 of 2 is equal to 365t. And what do we do now to get t all by itself? And so we see what that is. So alpha y equals, to make a fraction, on top, guys, in order to do log base 1 of 2, it needs to be alpha window option 5. Did y'all get a zero? Y'all get an error? Yeah. Yep. You know what my problem is? I shouldn't have probably done. What I ended up doing right there, guys? What did I end up doing there? Was that exactly 1? No, it wasn't. No, what has to happen now is I need to actually go back into the problem and write out what that really is. Yes, a bit lengthy, but the good thing is the calculator's doing the work, you're not. So log base of, and this is going to look ugly, but log base of, parentheses, 1 plus alpha y equals 0.025 over 365, close parentheses. If I could show you this, I would. Sorry, guys. If you do that, and it makes an ugly looking base. It's log base of 1 plus 0.025 over 365. Once you put that in, now you get an answer. You get an answer of 27.73 years. Okay? Because the rounding, you can't do 1. Which means 1 raised to what power gives you 2? Well, and you know that, guys, that you can't raise... Anytime you raise 1 to any power, it's not getting anything. But 1 raised to 1.0006489, that will increase. 1 by itself does not increase. But if you have a decimal, yeah, it's way out there, but guess what? It slowly will increase. So you do that, and you end up with the answer, 27.73 years. All right.
Did you round it up to 28?
If it says to round, Follow the instructions. What we have in the instructions, guys, I'll tell you this. On the test, it'll tell you to round to 3 decimal places. So round to 3 decimal places. So I shouldn't have done that there. I should have gone to. See ya. Yeah, I should have done that. 2, 7. There you go.